All right, we are starting. So this, I guess, is going to be FSA Review 6. Okay, this is number 32 on your packet, and this looks real crazy. This is right off the FSA website. So this is pretty cool. You can do this or that or even that. I'm going to leave it like this for a second, though. It says triangles BKW and DMT are shown, and then it tells us all this good stuff. We're going to come back to that. This question has 3 parts. Rashad performs a sequence of transformations on triangle BKW to map it onto DTM. So we are going from here to here. That part is going to be important. It says which sequence of transformations could be used to map this guy to that guy. When you have a problem like this, you are literally just going to check these options. So the first one says a translation of 8 up. So I'm just going to look at point B. If I go 8 up, 1, 2, 3, 4, 5, 6, 7, 8, and then a reflection across the y-axis, well, this guy would end up here. So that would be our B prime. And then from there, K would end up, let's see, here. Doesn't look right. Here. But that is going to wind up 7, -7. That guy would end up here, meaning the triangle is going to be faced this way. So is that one going to work? No. Nope. So move on. All right, for option B, it says a translation of left 10. So this is going to be 4, and then -6. So this right here would be B prime. And then a reflection across the x-axis, so this guy would end up here. Can I stop?
Yeah.
Yeah, that's not going to work. C says a translation of 10 left, so again we're going to end up here. And up 4. Oops, I shouldn't have put that dot there. We can just move it though. So that was 10 left, and then up 4. Oh, that looks good. And then a reflection across the line y is equal to 3. So this right here would be our mirror line. So I think this might be it. So if I go from K and I'm going to go 10 left, so this is what? 7, 1, 2, 3, and then up 1, 2, 3, 4. And then a reflection. So that right there is going to be K prime. Or K double prime, I should say, but that's all right. And then last but not least, the W. Oh, I think this is going to work. That's going to be what? 6, and then 4, and then up 4. And then 1, 2, 3, 4, 5. So 1, 2, 3. Uh-oh, I didn't count right. Is this 7? No. What was it? 10 left?
Yeah.
So this is what? 7, 8, 9, 10. There we go. And then up 4. 1, 2, 3, 4. Ah. Wait a minute. That was K again. Oops. 6, 4, 1, 2, 3, 4. So this guy is 1, 2, 3, 4 away. So now it's going to be 1. Okay, that's better. Good. That's our money. Man, gotta get my counting right. K double prime, so this would be what? W double prime, that's a tongue twister. And this is going to be B double prime. Okay, so that's our money right there. It was not D, it was C. Bloop. Are we good? Okay, on that note, this is the crazy part. This is saying, okay, this is part B. It is saying to use the add arrow tool to map the vertices of BKW to show the translations chosen in part A. So all we're going to do, guys, is we're going to move this guy, but it says translations. So are we actually going to do that reflection here? No, we're just going to talk about the translations. So this is a little tricky. But what we are going to do is we are going to take this guy and we are going to move it. Remember, we went left 10 and up 4. So that's what we're going to do. Add arrow, you click it. I'm going to go from B to there. That was left 10. And then from there, we go up. And I'm going to call this point B prime. This is kind of going to be a little bit of a headache, but we can do it. Add arrow, we're going to do the same thing to W. So we went left 10. And then we went up 4, so that guy there is going to be W prime. This is kind of fun, actually. Not really. Now we're going to do from K, left in, up 4, and what am I going to call that baby? K prime. And we're done. Do you guys have any questions about that? Notice how they added some random triangle over here. Be careful with that. All right, now it says he wants to justify, okay, this is the reading part. He wants to justify that angle B is congruent to angle D, K is congruent to T, and the segment. So this is what we were talking about before. Guys, we're just using rigid motions to map one triangle onto the other to show that they are congruent. Very nice. So what this says, okay, is by translating BKW so that B maps to B prime, then B prime coincides with, guys, B prime ends up going on D. Are we good? That is why we are allowed to say angle B is congruent to angle D, because you take the triangle that was here and we reflect it so that it lines up right there. So I'm going to write D. The outcome of reflecting the new guy is that K prime coincides with T. And W prime coincides with M. Because the definition of, very good, congruence in terms of rigid motions preserves distances and angles, then triangle BKW is congruent to triangle. Now, with these options, you want to make sure that the angles line up. So we are going BKW, B goes with D, K goes with T. So it's got to be that guy. Then it says, therefore, it talks about the angles being congruent in the sides. First of all, what does this mean, those bars right there? Absolute value, which makes sense. I mean, we're talking about segments here. Guys, once they say that these two triangles are congruent, here when they're talking about the corresponding parts, what would we say for the reason? Beautiful, Laura. CPCTC. And we are finito. All right, this is going to be our last one. Thank goodness. Come on in, ladies. We're recording, so say hi. All right, guys, this is a doozy, so bear with me. This says, oh, and this is number 35 on your packet, right? I skipped a few numbers for some reason. Your math teacher can't count. Natasha's classmates have ordered her a cookie pizza for her birthday celebration. That's nice. To share it among the class, they will be slicing the cookie into equal pieces. They want everyone to have an icing packet to add to his or her slice. In order to approximate how much icing each person will need, they want to know the area of each slice of the cookie. Phew! The following table lists the radius of the cookie pizza. Whoa! And the area of some of the possible division. So this is pretty cool, guys. I'm literally thinking about those big old cookies that people do for birthdays, right? And when we cut that up, what do each slice of cookie, what does that look like? Triangle. Almost, not a triangle, but like a pizza slice. You're on the right track here. Guys, what's the shape of a pizza slice? It's not a triangle. Sector. There you go. Remember, a triangle is like this. It's got to be curved because the outside is part of the circle. The cone is 3D. Be careful. This is super cool here. So they're talking about dividing it up. These are the measures of the central angles. The radius is always going to be 6. And now they're talking about the area of each sector. There you go. Or each slice of cookie. Obviously, the whole cookie is going to be the most. Half. That's too much cookie if you eat that. All right, let's check out the problem now. This problem is super, super tricky. That's why I'm spending time on it on that note. By the way, you guys can hit control down, like with your wheel of the mouse, to shrink it. You guys see that? No. Okay, or you can hit control and roll the wheel up, or you can do control plus or control minus, or you can look up here at these guys. And then this, of course, is your formula sheet. Sorry, I digress here, but where did it go? That's down here. Notice what it gives you, the conversions. Okay, it also is giving you time conversions. That's fun. I think you guys know that though. SOHCAHTOA, the easiest thing to remember. And then it gives you the volume formulas. But you got to know what these formulas are for. The first one, V is equal to big B times 8. No, big B means area of the base. And we're talking volume. So this is for a prism or for a cylinder. The next one, 1/3 big B times H. That is for a cone or a pyramid. Nice work. And then, oh man, are you going to let me scroll or no? It's got to be super small. Sorry. Whoa, too small. The next one, 4/3 pi r cubed. That is for a sphere. Very nice. And then, of course, y equals mx plus b. That's easy. Guys, if you see a problem in point slope form, put it into y equals mx plus b. It's just easier. Okay, back to the problem. My bad. This question has 3 parts. What is the relationship between the area of a whole cookie with radius of 6 units and the area of a portion whose central angle measures k degrees? So again, we are talking about sectors here. Okay? If we're talking about the relationship between the area of a whole cookie, what would we do?
So you need to
We're talking about sector area. Think about your formula for that. You take the central angle and you divide it by 360 because that's the portion that you want, and then you would multiply it by the area of the whole circle.
yeah.
So the answer here is going to be C, k over 360 times. That's how you find a percentage, guys, or the fraction that you want. That one's pretty easy. All right, part B. Use the information in the table. Click on the blank to complete the equation for finding the area of a portion of a cookie with a radius of 6 units when given the measure of a central angle in degrees. Whew. All right. On that note, if you click on this box here, this is when this problem gets weird. Okay, notice here how they actually give you K. They don't let me, like I'm hitting keys, they don't let you type in anything. I'm hitting, A they let me hit, F, D, they don't let you. So I'm telling you now, I'm going to use the letter K to show the central angle in this case, because they have it here. On that note, it is asking us to complete the equation for finding the area. Okay, so the radius is 6. Guys, we know this. We know our formula that we always use again is you take the measure of the arc, you divide that by 360. We're talking area, so you multiply it by pi r squared. Okay? Now we're just going to plug in what they gave us. Well, the measure of the central angle I want to use is going to be K. We're going to take that and divide it, where's my division sign, by 360. You know, I'm not really a big fan of that division sign like that. Here, let me blow this up a little bit too. I like to do it like this from my keyboard. I like to actually go, I like to hit that button, divided by 360. By the way, there's a fraction bar right here. You could also go that route. But I'm going to do this. I'm going to, oopsie, get out of here. No, I don't want that in here. Where's my mouse? Sorry, I have an extra parenthesis. Get out. There we go. Close parenthesis. So there's the portion that we want, and then we're going to multiply that by pi. What is the radius? 6. Can I go ahead and do 6 squared?
Yeah.
Which is what?
36.
36. That looks a little wonky, doesn't it?
About 36 bucks.
Yeah, but could I leave it like that? Yeah, you actually can leave it like that, but we know how we typically write it. Looks like this. We do 36 and then the pi button. Where are you, baby? Boop! So you are going to have to use this. Come here, dude. We're almost done, guys. Alright, that's how I'm going to leave it. Moving on. Click on the blank to complete the formula that can be used to find the area of any portion of a circle with radius W and central angle of Z degrees. Ugh, why? Whatever, this is how we like it. So where I see R, I'm going to put W, and where I see central angle, I'm going to put Z. That's it. So, real quick, I'm going to do this, and I'm going to say for M, we're going to put Z divided by 360, close parentheses, keeps doing that, there we go. And then we're multiplying that by pi r squared, so I'm going to do pi button, beep. And instead of R, oh look, they give you the letters. We're going to use W. Now this is pretty cool. This is my square button right here. And I'm going to put a little 2. Maybe. 2. Here, let me blow that up so you guys can see it in the class. Does that look good? Guess what? We're done. Finally. Those problems are a lot of reading. All right. Good luck, everybody. Now we're going to shut this off. 15 minutes. That's not bad. All right. Happy studying. 8.